Hi, Algebra 1. In this lesson 10, it's going to be the first part of looking at domain and range, and we're going to be looking at all the possible inputs and outputs for a function. Here we go. Here we're revisiting our dog on a leash, and we're looking at the total number of times a dog has barked as a function of the time in seconds after its owner left. And let's remember that less than 3 minutes after he left, the owner returned, untied the leash, and walked away with the dog. So number one, could each value be an input of the function? Remember, that's our independent variable or our x values. 15 and 84.5 could be possible x values the seconds after the owner left. 300 does not work here because that's past 3 minutes. And we know by that time the owner had come back. In number two, could each value be an output of the function? That is looking at y values, the total number of barks. In this one, we can see that 15 could be a possibility. 300 could also be a possibility for the number of times a dog barked. It'd be a lot, but it is possible. 84.5 is not going to work here because a number of barks has to be a whole number. Here we are revisiting the function a of s is giving the area of a square with side length s, and we calculate that by the rule s squared. So to visualize that, I have a square here. Here's the graph of that function. First, we're going to name three possible input-output pairs. Input is x, output is y values. Here would be the outputs for these inputs. The important thing here to recognize is that 0 is a possible input. We could have a square with side length 0, there just wouldn't be anything there. And we can have side lengths of decimals and fractions. B says that earlier we described the set of all possible input values of A as any number greater than or equal to 0. That means all our possible x values. It could be anything greater than or equal to 0. How would we describe the set of all possible output values? Those are our y values. Well, we would probably say the exact same thing here. Any number greater than or equal to 0. Another way to put this into mathematical terms would be y is going to be greater than or equal to 0. On our graph, every single y value is going to be greater than or equal to 0. Function r is given by r of n equals 40 times n. And this is dealing with campers at a tennis camp. N is the number of campers. There has to be between 5 and 16 of them in order to run the camp, and each camper is going to pay $40. That's where that 40 is coming from. Is 20 a possible output value in this situation? I'm looking at my y values and my number of campers here. There is no possible way that I'm going to end up with an output of 20 because even if there's one camper, I would still get $40. What about 100? Well, it told us earlier in the problem that there has to be at least 5 campers. So that's where 5 times 40 is going to be 200. So I'm going to be having at least 200 as an output. So neither one of these are possible outputs. These are two possible graphs that are showing the number of students and how much money we're making. Which one could represent function r? The best answer here is going to be this graph right here. This best shows function r because we can't have any values of money that are between the numbers of campers. So for example, if I have 5 campers, I'm going to make $200. If I have 6 campers, I'm going to make $240. I can't be making anything in between here because I can't have partial numbers of campers. So the possible inputs in this function are going to be the whole numbers that are greater than or equal to 5, but less than 16 we should add on to there. And remember that the inputs are the x values. That's going to be our number of campers. What are the possible values for that? C is asking about all the possible output values for R, so that's going to be all of the possible y values here. And as we notice that it's going to start at $200 and then it's going to be adding $40 on for each camper. So it's going to be multiples of 40 starting at 200. It's starting at 200 because we have to have at least 5 campers to begin with. And then from there we're adding on 40 each time. Here we're looking at this function right here. And first thing, we have Claire. She's going to be creating a table. It's going to be right here. We're looking at different values of x, and we're going to evaluate the function. So plug in these different values for x into your table. When I plug in these values for x, I get -1/2, -3, -4, and then I run into some trouble right here. I wrote it in red because it didn't work. And I have 6 over 2 minus 2. That's going to be 6 divided by 0. I cannot divide by 0. So at this value for x, that function is undefined, we're going to say. And then, once again, 8 works at the end. Number 4 is saying, how would you describe the domain of function f? Domain is going to be all the possible inputs, so values for x that we can plug into this function. And really it's going to be anything except 2. Because if x is 2, then the denominator is 0. We cannot divide by 0. But as long as x is anything besides that, we can evaluate this function and find an output just fine. In your lesson summary, you have 2 important bold words with definitions. First is the domain of a function, and it's going to be the set of all the possible input values. Those are your possible x values, and we can also think of them as your independent variables. And we're just looking at what are all the possible values. Depending on the situation, it's going to be different. It could be all the numbers, it could be just whole numbers, it could be all the numbers that are greater than 0. So depending on the situation, the domain is going to be different. Very similar for the range of a function, it's going to be all of the possible output values, or in this case, in any case, that's your possible y values. And that's also going to be your possible dependent variable. And again, once you know the situation, once you know the domain, it can help you find the range. It could be all numbers, it could be all positive numbers, it could be all numbers except for one certain value, it could be just whole numbers, whatever it might be, but we're looking at all the possible output values.